All right, this is exercise 3.6. What we're going to do is draw a retention pond that is 2 feet deep. It doesn't say this on the paper, but I'll make sure it's on the paper that's the PDF that's available. Pond depth equals 2 feet. Minimum slope is 2%, maximum slope 3 to 1. That means the side slope of your pond is going to be 3 to 1. The minimum slope of your swell is 2%. It can be steeper than 2%, but the minimum slope is 2%. We know that these are 1 foot contours, 50, 51, 52. We know the retention pond, the low point of the retention pond is 45. Pond depth is 2 feet, which means that the top of the pond is going to be elevation 47. And we know that the high point of the swell, this is the center line of the swell going down to the pond, the high point of the swell is 50.5. So with that, we can get started. First thing we should do, we know that we need 2 contours around this pond, right? We need because the bottom, this is the bottom of the pond, which is elevation. This dashed line here is contour 45. Essentially, we'll have contour 46 and contour 47. That'll give us a 2 foot deep pond, and those are going to be 3 feet apart. If you have more room, you can go wider, but since they told us 3 feet, we will just draw 3, 6, and this is at 20 scale. So we'll put 3, 6. This is 3, 6, and another one over here, 3, 6. So what we've got basically, and over here, contour line over here. I'm just drawing these lines 3 feet away, parallel with that bottom contour of the pond. So we'll just go. If you use your straight edge, you can get nice clean lines that will look better graphically. One here, and then just kind of connect those. It's a nice curve around the sides, like that. Do this one over here. That and that, and then we'll do here and here. So that is contour. This is contour 45. This would be 46, and this is contour 47. So this is the top of your pond. Now you'll notice here this is contour 46. So we got to go. You need an embankment or a dam on this side. Remember, when the water comes down, this pond fills, you want the end of the edge of the pond on the lower end to be higher. Otherwise, if it filled up, water could just overflow and flood the area downstream. So what we want to do in the book, they say to make it 6 inches to a foot taller than the elevation of your pond, the high elevation of your pond. This is 47. I like to use 47.5 because half foot easy. It's not so that we can have the 47-foot contour on the uphill side, and then it'll go to 47.5. Then we'll have to have 47 again on the low side. Let me draw that, and hopefully that'll make sense. So if it's 3 to 1, and we're going to go a foot higher, or half a foot higher at 3 to 1, we only have to have these 1.5 feet apart, right? So 1 foot, 2 foot, 1.5 foot, 2 foot, it doesn't matter. I mean, that's the maximum slope. So you can go 4 to 1 or 5 to 1, but we'll call that elevation 47.5. And that is our embankment. We'll call it a dam. So you're going to have elevation 45, and then it's got to go down to 47. So this is 47 here. So 47 is going to have to, if this is 47, then we got to have 46 3 feet apart, right? So now here's 47, here's contour 47. So we've got to come over here. I'm just going to break this so it doesn't go over like that. So if we come this way, like this, we can tie into 47. Contour 47, it goes up to 47.5, then goes back down to 47. And then if we do that, then 46 is here. We've got to pull it 3 feet away, which is why we've got to meet grade right here. And then there's 45, and that's more than 3 feet. So we're good on this end now. We've created our pond and our dam. So what else do we know now? We know that minimum slope is 2%. We know that this is contour 47, this is contour 50.5. We don't know, so what we've got to do is figure out what the slope is here and make sure that it's more than 2%. And how do we do that? Well, slope, I'll write it here, slope equals vertical divided by horizontal. So we don't know the slope, but we know the vertical is 50.5 minus 47. Let's contour 47. That equals 50.5 minus 47 equals 3.5. So we know that our vertical drop from here to here is 3.5 feet. And we know that horizontal distance, we can measure that with our scale, and it is 10, 20, 30, 40, 50, 65 feet. 65 feet at 20 scale. So we go 3.5 divided by 65 equals, 65. So 3.5 divided by 3.5 divided by 65 equals 5.38. So we'll just call it, it's 0. I'll write it out so you can see. Instead of rounding it off, I'll just go 0.05384. 5384. And it goes on, but we'll just call it, so that is, we can call that 5.4%, right? 0.538. I just rounded up to 5.4. So this is 5.4%. So if we know that it's 5.4%, we got to drop a half foot from here, right? This is 50.5. We're going downhill, so we got to find the nearest whole contour, which would be contour 50, which is a half a foot vertically the drop. We don't know what the horizontal is. Write this up here so it stays on the page. Horizontal equals vertical divided by slope. So we know the vertical is half a foot. We got to drop half a foot from 50.5 down to 50. We got to divide that by the slope, which we said was 5.4, or is 0.045. You can go 0.05. Oops. 0.0538. You can do 5.4, it'll be close enough where you can do the 5.38. What does that equal? 0.5 divided by 0.0538 equals 9.29. So we'll call that 9.3 feet. So if we measure 9.3 feet, puts us right about here. That's contour 50. Now we got to drop from 50 to 49, 48, 40, and then we'll be to 47. So 1 foot of drop. So instead of 0.5, we use 1 divided by, still on the page there, 0.0538 equals, should be 18.6, right? So 1 divided by 0.5, nope, clear. 1 divided by 0.0538 equals 18.6, which makes sense because if this is half a foot and that's 1 foot, this number should be double this number. So we know that we got to go 18.6 feet. There's 18.6. And we got to go another 18.6, which is right there. So that's 49. And this is 48. And then there's 47. 47's right there. So 47 ties in here. 48 has to go up to here. 49 has to tie back in. And then 50 has to tie. So let's go ahead and now remember you only have to be three feet apart max. So you don't have to go way out here to tie back in. See this 3 feet? That just results in more grading. So if you keep it fairly close, like that, less grading. Less grading means less cost in the field. So then this one will just come around like that, come here like that. So then this one, 49, we got to tie in 3 feet. So we'll come down here like that. This one, same thing, 3 feet roughly there. So we'll just come like this, like that. Another 3 feet. Like that. This one has to come down like that. All right, now 51 would have to go up around as well, but it's off the page here. It's up here, so don't worry about that. As long as you've got these three, you're okay. And then that makes this swell going this way is 5.4%. 0.4%. And that's it. You've just solved the problem. You could put up here if you want. Here, that's 3 to 1 max. 3 to 1 max. So there you go. You just solved the problem. Now for the homework, it's slightly different in that they didn't give you, I just want to show you real quick, bring this into focus. They didn't give you a pond shape down here, the base of the pond, so you have to draw it yourself. So everybody's pond is going to be a little different, but just start with what you know. You know that if you see here, the bottom of the pond is 323, has to have 5 to 1 side slopes. If the bottom of the pond is 323 and the depth's at 3 feet, it's going to be 326 is going to be the top of your pond. So if you just come down here, what did I say, 323 plus 3 feet gets you 326, right? 323 plus 3 feet depth, contour 326 would be the top of your pond. So your dam is going to be, or your embankment is going to be 326.5. So if you come down here and you put your 327, you know, if you put, here's 326, so if you put this is about 326.5 naturally. So if you put your embankment right here, right, because there's 326, 327, and we know the top of your embankment is going to be 326.5. You've got this 326.5. Now you can just work, you've got your 5 to 1 contours, and you can just work your way back. You can go, you know, it'd be 2.5 feet, right? You'd put a contour, you could work your way down to the bottom of your pond. So there's 326, 25, 24, 23. And then you can just draw in the pond. Since they didn't say how big it needs to be, just draw in any shape you want. And then draw your, now you can work your way up this side, right? With your contours being 5 to 1, because on this exercise, again, sorry, this page is so big it doesn't fit on the, but 5 to 1, you can just draw, if these are 5 feet apart, you just draw your contours, you know, like this. Make sure these are 5 to 1 max, and then work your way up to the top, and you'll get the top of your pond, and then all you got to do is calculate the slope between those two elevations that you have. You'll have the horizontal distance, you'll have the vertical, you just want to have the slope. Calculate your slope and then locate your contours, and that's how you solve this problem. I don't want to do it for you because it's homework, but that's, I just wanted you to know they didn't give you that information. You make it so everybody's in class will look a little different, but this is essentially what you'll have when you're done.